Let's take a look at number 15 in section 3.3. We're going to calculate the derivative for this particular function. So I'm going to show you actually three ways of doing this. They're all, of course, going to yield the same result. We're going to use the product rule in all of the methods. Just a reminder, the product rule, the product of two functions, f times g, will be the derivative of the first function times the second, plus the first function times the derivative of the second. So remember, we derived that. And so method one will make use of that, of course. We're going to think of this as e to the x as one function, and the other function is x squared plus 5 times x plus 2. So I take the derivative of e to the x times all of that plus e to the x times the derivative of all this. Okay, over here, derivative of e to the x we know is just e to the x. That's the simple derivative that we're going to use. So always remember that's not a power rule, right? The derivative of e to the x, because here the base is constant, the exponent is variable. That's the one easy rule. And we're going to talk more about the general exponential function derivatives later. Now, when we take the derivative of this second part here, notice I've got a product again, x squared plus 5 times x plus 2. So I could use the product rule on that. I take the derivative of x squared plus 5, which is 2x, times the x plus 2, plus the x squared plus 5, times the derivative of x plus 2, which is just 1. And so cleaning that up, distributing the 2x through the x plus 2, and adding the x squared plus 5, combining like terms gives me that as my derivative of that. And so here I am, I have e to the x times this stuff, which I'll go ahead and FOIL that out in anticipation of simplifying this. X squared times x is x cubed, the outer is 2x squared, the inner is 5x, and the last 5 times 2 is 10. Of course, I have e to the x times the derivative of this stuff, which I'm just going to recopy that. And then you'll see I can simplify. I have a common factor of e to the x here, which comes out leaving this stuff in parentheses here, plus this stuff, right, in parentheses here. And now all this stuff here can be simplified because I have like terms. So I've got x cubed, 2x squared plus 3x squared is 5x squared, 5x plus 4x is 9x, 10 plus 5 is 15. And there is your final result. Now, you might note that, hey, we could actually maybe simplify this a little bit. When we go to the original expression here, what if I were to simplify? We foiled this out here, going from this point to this point, right? Foil that out. What if we just start out by foiling that out first, right? We get this. Now the derivative is just, the derivative of e to the x times all this stuff, which we've just expanded out, plus e to the x times the derivative of all this stuff. Well, now we don't have to use the product rule essentially here. Derivative of x cubed is 3x squared, derivative of 2x squared is 4x, derivative of 5x is 5, derivative of 10 is 0. And we get that. Of course, that's what we got when we did use the product rule. And then I go ahead and factor out the e to the x. Everything from here on down is the same as we did in the first method. Okay, so there's two methods that get you the same result. One more method which will give you the same result, and we talked about this in class or in my lectures. Um, the derivative of a product of three functions, what will that be? Well, I can use the product rule thinking of fg as one function and h as another. So I'll take the derivative of fg times h plus fg times the derivative of h. But when I take the derivative of fg right here, that's a product rule again. How do I find the derivative of that? I take the derivative of f times g plus f times the derivative of g. Now this is all multiplied by h. I just recopy this, and then I distribute the h through here. And here's what I end up with then, right? And take a look at this very carefully, what this is saying. If I have the derivative of three functions, how do I do it? Well, I take the derivative of the first function times the second and third, plus the derivative of the second one times the first and third, times the derivative of the last one times the first second. And so all you have to do is think of that pattern. So if I'm actually taking the derivative of four functions, I just take the derivative of the first one times the other three, derivative of the second one times the other three, derivative of the third one times the other three, derivative of the fourth one times the first three, add all those products together, and that's your derivative. So in this case here, I could do that same idea, thinking of three functions now, e to the x, x squared plus 5, and x plus 2. So I take the derivative of e to the x times the second two, the derivative of x squared plus 5 times the first and the third, and the derivative of x plus 2 times the first and the second. Derivative of e to the x is just e to the x. Derivative of x squared plus 5 is 2x. and the derivative of x plus 2 is just 1. I get that. And now I can factor out the e to the x from all of these, expand all this out, algebra, blah, blah, blah. But if you simplify it, lo and behold, you get the same thing that we got in the previous two. Okay, so just a couple ways to think about these problems. You can use product rule straight up, or you can simplify first. You still have to use the product rule no matter what on this one. Okay, hope this helps.